Okay, so let's be real. AI is everywhere. It's completely transforming our world. But you've seen those scary headlines, right? The ones screaming that this AI revolution is an environmental catastrophe. So, what's actually going on? It really all comes down to this one question. Is AI's energy use just completely out of control? That's the big worry on everyone's mind. And today, we're going to slice right through all that noise and get to what the data actually says. Let's get into it. All right, first things first. The moment you start looking into this, you realize something weird. The numbers are, well, they're all over the map. So to even get close to an answer, we first have to figure out, why is this so confusing? Why can't we just get a straight answer? I mean, just take a look at this. For a single AI prompt, one study from epoch.ai says it's about zero point 0.3 watt-hours. But then you have the famous de Vries estimate, and suddenly it's 10 times that much, 3 watt-hours. And some calculators push it even higher. I mean, wow, no wonder everyone's confused. This huge gap is exactly the problem. So what gives? Why are these numbers so wildly different? Well, it turns out it all comes down to one really important but kind of simple idea: where you draw the line. Yeah, there's a technical term for it. It's called the measurement boundary. Think of it like drawing a circle. Everything inside the circle gets counted, and everything outside doesn't. And as you can probably guess, not everyone draws their circle in the same place. And this is where it all clicks into place. A lot of the estimates you see out there, they only measure one thing: the AI chip itself, the accelerator when it's working hard. But that's like measuring a car's fuel use by only looking at the engine and ignoring the wheels, the air conditioning, and everything else. A real comprehensive look has to include the computer's brain, the CPU and memory, the energy that's used just keeping machines on and idle, and, the energy for the entire data center building, like all the cooling systems. Okay, so what happens when you actually do that? When you take this big picture, full system approach and apply it to a massive model like Google's Gemini? Well, let's just say the results might surprise you. The number is 0.24 watt-hours, and that's not a lab test. That's the median energy for one text prompt measuring the whole shebang, the full stack in a real live data center. But, 0.24 watt-hours, that's just a number, right? What does that even mean in the real world? Well, think about your TV. A single prompt on Gemini uses less energy than watching just 9 seconds of your favorite show. Not so scary now, is it? And hey, what about water? That's another big concern we hear a lot about. Well, with that same comprehensive measurement, it turns out one prompt uses just 0.26 milliliters of water. To put that in perspective for you, that's literally about 5 drops of water. That's it. Compare that to some of the scary numbers out there. We're talking a whole different ballgame. Okay, and this is where it gets really interesting. Check out this breakdown. The AI chip itself, the part that almost everyone else measures, that's only 58% of the energy. Almost half, 42%, comes from everything else: the CPU, the idle machines, the building's overhead. This just proves why measuring only the chip gives you a totally misleading picture. So you're probably thinking, okay, that number is way lower than I thought. But how on earth did it get so low? It's not just about measuring right. It's about something even more amazing: a crazy leap in efficiency. All right, brace yourself for this next number, because it is wild. In just 1 year, from May 2023 to May 2024, the total emissions from a single Gemini prompt dropped by a factor of 44. Let me say that again: 44 times more efficient in 1 year. That's not just an improvement, that's a revolution. So how did they pull that off? It wasn't one single thing. It was a 1-2 punch. First, a huge 33x drop in the amount of energy needed, thanks to smarter tech. And then, on top of that, they used cleaner electricity, which cut the carbon intensity even more. So this is the secret sauce, right? It's all about optimizing the entire stack, from top to bottom. We're talking smarter models that are like a team of specialists, only waking up the one expert you need for the job. We're talking clever new algorithms and tricks that get you the answer way faster. And all of that is running on custom-built hardware, TPUs, inside some of the most hyper-efficient data centers ever built. It's the whole package. Okay, let's zoom out. We've seen that how you measure is critical, and we've seen that these mind-blowing efficiency gains are possible. So what's the big lesson here? What does this all mean for the future of AI? It really boils down to this. If we're going to have a serious, grown-up conversation about AI in the environment, we all have to be playing by the same rules. We need one standardized, comprehensive way to measure this stuff. Otherwise, we're just comparing apples to oranges and nobody gets anywhere. So here's the thought I want to leave you with. Right now, the footprint of one prompt is tiny. But think about it. As AI scales up to billions of people using it every day, those tiny drops start to fill a bucket. So the real question isn't just about today's numbers, it's about our future. What standards should we, all of us, demand for measuring and managing the footprint of this incredible technology?